All right, so let's talk about some more transformations. This is a multiply in front. It is meant to make it stretch and go 3 times what? Taller. That's correct. Question. Yes, you may use the charger. Come on up. All right, so this would take my normal graph, which looks like that, and make it 3 times as tall. I want you to go off to the side and make me a little sketch of what 3 times as tall would look like. I think some people are going to like put it like that, and that would be wrong. Try to stretch it and make it 3 times as tall. Push the silver button. All right, so that spot right there would be one of my important points. When I make that 3 times as tall, how tall is it right now? 0. It's not up at all. It's at 0, so it's 0 tall. So that one won't move. This one was at 1, 1, and that will get 3 times as tall. So that one will go up to, not 3, 3, 1, 3. There you go. And then this one was at 4, 2 right there, and it'll go to 4, 6. So your new points again, this one isn't tall at all, so it stays short. This one goes to 3 times as tall as it was, and this one's 3 times as tall as it was. Should look something like that. Raise your hand if you did yours generally right. Okay, good. Looking over at this one, I'm seeing 2 things, and I've taught you what order these should go in. Parentheses are normally first. So we don't do those parentheses first. We do the negative first. So if I was calling this A and B, A would be first and B would be second. Okay, so then how do I start? I start with the same parent. I still got it on my screen here. It's that red little line right here. Okay, so it's that parent, and where do I move it? Well, first I should do this. That's a which way flip? Left, right flip. So then your new picture would kind of look like that. And then how do I do that right 5 after that? I just grab this and move it up to the right 5. 1, 2, 3, 4, 5, and there we go. Generally, it looks like that. Correct. There was no stretching in that one. It was just a flip and a move. All right. How do you know? Well, if it's multiplying out in front, that's going to be some kind of a stretch. All these other things have stayed the same. They haven't changed a bit. If it's minus 5 on the inside, that's 5 to the right. This negatives are always just flips. All right, so then this one right here. That's confusing because you've got that divide by 2 on the left-hand side, but you can fix that easy. Yes. Yeah, multiply by 2 on both sides, and then all of a sudden I'm going to put the 2 in front, so it's logical. That 2 cancels, and you have the 2 in the front now. So now it's a times 2. It's twice as tall. So on this one, I don't even need you to draw me the picture, but would you tell me what are the 3 things you do to this? And I'm going to see how many of you are smart enough to handle that 4, because that's kind of weird, but tell me what this, this, and this do. And I'm especially curious to see how many of you know what that 4 does. Yes, come on up. Bring me something to trade. Just like collateral. That'll work. I won't want to, you will want that back, obviously. So, yes. That'll work. All right, so I hope you knew that this is 2 times taller. How about that 4? Raise your hand if you have a good feeling about this one. Only 2 brave people. I'm going to go with Miss A right there. 4 times wider. Okay, so would you agree that this really means 1/4 x? Now, does that help you see that it's 4 times wider? All right. So when it's over 4 like this, that means 1/4. All right, so that's 4 times wider. And the last one was the -1, which would be where? Down 1. Now, if you were just to answer this, if I call these A, B, and C, what order should you do it in? What letter is first? B, and then A, and then C. All right. This one's more complicated because it's got so many things going on. Right away, I can take that divide by 5 and make it a times 5 in the front. Do you get that? And I can take that +4 and make it a -4 over here. Do you get that? Okay. Then it's got 4 things happening. I'm going to call them A, B, C, and D. I want you to tell me in the right order which one should be first, second, third, and fourth. Should it be CBDA, etc.? Okay, write down the 4 things that it should, the order that it should go in. The order is the hardest part, and I am teaching you this above and beyond what I have to teach you. I'm teaching you the order that you'd need for pre-calc. All right. So I recommend you start on the inside. So if you didn't start with B or C, you're kind of missing the boat right off the bat. How many of you started with one of those two? Okay, that's pretty much everybody. Good. And then which one should you start with? Parentheses are normally first, so they're not first. B, this thing, would be first. So B and then C. And then once you're on the outside, you do it in the normal order of operations. And this is a multiply, which comes before subtract. So it should be AD. Raise your hand if you had BCAD. Awesome. Okay, now I got a really hard one for you. And I want you to enter the answer into the response app that we just made. Free response app. Remember? Well, it's you could call it an app. It's just a link. But on your iPad, I want to make it a link. So everybody take this, get it back up on the screen. All right, if you're having trouble, go back to Schoology and download it from there. I'll show you where it is in Schoology. So go to Schoology. Once you're in Schoology, go to Files, don't talk, go to Files and Links. Once you're in Files and Links, touch Free Response Link. Okay, and it pulls up something that looks like this. All right, and now it's gonna tell you what your info is that you already signed in as, and then you can type your answer in. Well, up at the top of your page, there is a little thing that looks like this on top of your page. Listen, listen. See that little thing up there next to the address bar that's got that www dot blah blah blah? Okay, touch that and it'll pull up several options. One is add to home screen. Okay, and then in a second I'm going to ask you to show me that you did it. So do this right now, and if you're lost, ask for help. Add to home screen. Touch this. All right. I could probably show you that. I don't know if this is going to show up on the video at home or not, but I'll probably show you that in my iPad. See if I can do this quick. Switch this to HDMI. And then it'll be interesting to see if this comes through on the recording or not. No, I don't want that right now. Then I gotta pull this up and that. There we go. Come on. There it is. Okay, good. So now, once you're in this, to get this to come up at the top here, see that little guy right at the top? Do you have that on yours? All right, good. So then you should be able to just say, add to home screen. I keep touching the smartboard. Add to home screen. There we go. Call it free response. Say add. So tempting to touch that on the screen. And there we go. Okay. So I'm going to walk around and show me that you've got that working on yours. I'm going to go back to my computer here. I just want to see the little link that you created. And if you have trouble with it, ask me and I'll show you quick. Good. I checked them and they're all there. Awesome. So now you've made a little app. I call it an app. It's really a link. But now whenever I ask you to, I can say, hey, go to your free response app. That's what I'm going to call it. And you can just type in your answer there and it'll show up on my screen. So you saw that before. Right now I'd like you to try this problem. I'm going to write on the board here for people at home. Y equals negative 1/2 square root of negative 2x plus 7. I'm changing it slightly because I want to make it a little harder. Plus 8. And I'm going to call this A, B, C, D, E, and F. Not many people are going to know exactly what order to do this one in. Now I'm going to give you one last hint that helps you. You know, the hardest one is going to be deciding. I think most of you will know that you're going to start with either C or D. Okay? And how do you decide between those two? I'm going to give you a gymnastics analogy for this girl in the front row. Yeah, a couple. Wouldn't you say, if you're going to do these two things, that there's a right order to do them in gymnastics? You're going to flip. You're going to do a stretch. Would there be a logical order in which to do that? No, you would stretch first before you flip. You don't want to pop an Achilles tendon or whatever because you didn't stretch out first. So what I'm trying to say is, in math, you should stretch before you flip. I think you will. All right. So now, this is the tricky part, though, because we're underneath that square root thing, and so everything's counterintuitive, and so, you know. So if you think it's C, E, D, F, B, A, well, then type that in the free response app. Like this. C, E, D, it's not right, but F, B, A. So type this in, and I will see who answers first correctly. Give it a shot. Well, even if you're not first, now you know you're not going to be first because several people have gotten there before you. At least get it right. Because this is a hard one. I'm going to predict only 1/4 of you are going to have it right. We will see. It will not tell you if you're right or not. I am going to pop it up on the screen, and I'll tell you what's right, and we'll know. It tells me what time you sent it, and it tells me what you thought the answer was. It's really hard for it to graph answers like C, E, F, B, A. You know what I mean? If you have numbers like, if you were answering things like 6 or 7, then it can lump them together and make a graph, yes. But not things like they're weird, like C, E, F, B, A. All right. Normal order of operations is to stretch before you flip. Yes, you can, but it won't change your original response. It'll just add a second response. So if you know now that your first response was wrong, at least you will have, if you enter it again, at least you'll have given me the right answer as well as the wrong answer. I would assume your second one was better than your first one. All right. So now, I'm going to pause for just a moment in my video because I don't want to be surprised at what I see on the screen. All right. So now I'm going to tell you what the right answer was. If you start on the inside here, obviously your choices are C, D, or E. Normally parentheses are first, so they are not first, so it can't be E. Now, of the other two, normally you stretch before you flip, and therefore you should flip before you stretch. And so it's C, and then D, and then E. Then stuff on the outside is the A and the B and the F, but what order? Stretch before you flip. So B, A, F. C, D, E, B, A, F. C, D, E, B, A, F. So now, I'm going to go over to that other screen. Pause for a second to do that. C, D, E, B. Okay, so used a lot of cool technology there that you couldn't see at home, unfortunately, but still pretty cool. All right, so the graph, if you were going to graph this one, you'd start by knowing it's a parabola because it's got a square. And then it's a parabola that's had some work done. Kind of like the people that have, you know, their nose job done or whatever. You believe that's getting to be really common for teenagers? To have nose jobs as a teenager. And There's even people that are having breast implants as teenagers. And it is, in my opinion, kind of messed up. Now, I understand there are some cosmetic things that are absolutely needed. You know, like there's cleft palate, for instance, where if you've ever seen that person has a little cut in the front of their lip, and their lip is separate and stuff, and it just makes sense if you're really young to do that. But there's a lot of like optional surgeries that people are doing younger and younger. It's kind of scary. Almost makes me think of that Honey Boo Boo show. Any of you actually seen this? It's a sign that the end of the world is actually coming. Awesome. Okay, so Honey Boo Boo, you watched Honey Boo Boo all night. All right. Anyway. Oh, Here Comes Honey Boo Boo is the official name? Okay. It's about the little girl. How old's the little girl that's doing this? 6-year-old girl, 7-year-old girl that's in beauty pageants? All right. So I brought that up because if you look at a parabola like this, it's had some work done. It's had some like adjustments to its look. Okay. This 3 right here just means I moved it over. That's pretty simple. So it's moved over 3 spots to the right. So I can, because I got a Neato smartboard thing, just take this and move it so that my graph actually moves 3 spots to the right. And then the up 2, no, that's not an up 2. What's that 2 mean? It means twice as this 2 right here. Twice as tall. So all my points need to become twice as tall. So instead of over 1 and up 1, I go over 1 and up 2. This point moves up to here. This point, instead of going up 4, it's going to go up to 8. And this point's also at 8. So my new look ends up being actually a little narrower, even though it's supposed to just be stretched up. But if you look at what the old one would have looked like and the new one looks narrower, but it's actually being stretched up. Again, each point went up. See, here's a point going up. Here's a point going up. This point here went up to there. This point here went up to there. So it's sometimes hard to tell a stretch from a shrink. All right, on this one, what would be first? What would be first? The +4 or the 1/2? The 1/2. So it would get vertically shorter, and then it would move which way? That's not to the right. That's not to the left. You go through them all, eventually get it right. Yes, it's up. All right. So I think I want to now look at this kind, because these sometimes blow people's minds. Everybody turn to this page. Flip to this page, please. Page 7, I guess. All right. Now this one is simple because it hasn't been stretched. I want you to write me the equation for that one. It has not been stretched. Just write me that one because it should be easy. Okay, right now. Do C. As in cucumber. Page 7. And I'm doing C as in cucumber. Okay, would you agree that it's an absolute value? Would you agree that there's a 3 involved? All right, because it moved 3 to the left, so how do I do that? +3, and then it went up 2, so I go +2. All right, now B is significantly harder because it's also been moved, but it's also been stretched and flipped. Give B your best shot. I will tell you there's 2 correct ways you could do it. You can do this as a vertical stretch or as a horizontal stretch. Either way could work. Give it a shot. Just give it a try, and I'll show you what I mean in a second. I don't want to just tell you the answer. Obviously, there's an X involved. It isn't obvious. It moved 3 to the left, so there is a +3 involved. And then it moved up 1, so there's a +1 involved. That's all the easy parts. So then, it was flipped, so what kind of a flip? A left, right, or an up-down? Up-down, so there's negatives on the outside. That's a no-brainer. That's easy. Okay, and the last one is the hard part. So that it's been stretched. Now, look at it this way. From that spot, don't you normally go over one and up one like that for a normal V? But since it's upside down, we would go over one and down one because it's upside down. Do you get what I'm saying? It would be like this if it was normal. Okay, do you get that you could look at this as a stretch and it got wider? Do you get that you could think of this as a squish and vertically it got shorter? Either way could work. All right, so if I'm looking at this one, I would compare it to the points 1, 1 where I would expect it normally to be. And I would say, okay, I could say this thing got twice as wide as it was. Because normally it would be here, and instead it's over there. Get the difference in width is 2 compared to 1. So it's either, just wait a minute, so it's twice as wide. So if it's twice as wide, do you get that that would mean I would not put a 2 on the inside, I would put a 1/2 on the inside. And then you need parentheses around there. Did anybody do it that way? Okay, good. Now there's another alternative way. Everything's the same, negative in front, x plus 3 on the inside, plus 1, but then the negative, sorry, then the 1/2 thing, you could say it got half as tall, and you could have put the half on the outside. Raise your hand if you did it that way. That also would work. Because look at it. See, instead of going over 1 and up 1, it went over 1 and then down only a half. That's half as tall as it used to be. All right, so that was a tough one. All right, let's look at D. Was D stretched or not? Right away, I can tell. Was not stretched because the normal spots are over 1 and up 1, and this one over 1 and down 1. That means it was flipped, but it was not stretched. All right. Let me just clear up my page here. And you can tell me, is there, on A as an apple, was A as an apple stretched or not? What are the normal points? You start here, then you go over 1, up 1. It's going through the normal points, isn't it? I'll give you a clue. Pretty much every graph goes through over 1, up 1. You ever thought of that? The V shape goes through over 1, up 1. The square root shape goes through over 1, up 1. The parabola goes through over 1, up 1. So that's a great spot to tell whether something's been stretched or not. So I start here at the vertex and I say, that's over 1, up 1, except it's down 1. This one, over 1, up 1, so it didn't get stretched. This one, it's over 1 and up. Wait a minute, that one got stretched. See what I mean? That's how you can tell if they were stretched or not. All right, these kind of are easy. It's just, okay, I got y equals absolute value of x, and I got to do some stuff to it. Shrunk by a factor of 4. Horizontally. That means on the inside. Do I put a 4 or a 1/4? It's shrunk. To make it shrink, should I use a 4 or a 1/4? 4, because it's counterintuitive. Seems like that makes it 4 times bigger, but it's actually going to shrink it. Okay? And then reflect it over the x-axis. Let's see, which axis is that? That's like going this way. That's up-down. That's an up-down flip. Negative. And then translate it up 5. Up 5. Didn't go left or right, so there's nothing in here. Just leave that. You get that? All right, I think you've got enough learning under your belt here, so you're going to be okay. Your assignment is, it says only do problems 1 through 3, but problem 1 has like A, B, C, D, E, and F. And problem 2 has like A, B, C, and D. So it seems like it's really short, but it's not that short because problems 1, 2, and 3 have so many multiple parts. All right, but it is doable. I encourage you to do your graphs today by using dots. Because if you try to connect your dots, that's where it's going to look really sketchy. It's really hard to make them nice, clean. So if you want to just use dots, that would be totally okay. So I'm showing you where it is here. It's under assignments, and today's date is the 2nd. So I look here, and it says 1 through 3 only. See on the third one down there? 1 through 3 only. Okay, and then within that, think it just popped up on here. There we go. All right. So you would open it in your Remarks app. And then for the first one, I would always start by sketching the parent function if it were me. I'd put the dots of the parent function on here. Over 9, 7, 8, 9, and up 3. There's the parent function. Now it'll be easier for me to sketch the stretch that they want. I'm going to do that in red. And this, remember, this means 1/2 x. Remember that? So now think to yourself, do I want to make it half as wide or twice as wide? Twice as wide. So this thing has to get stretched. That dot does not stretch at all. This, instead of being where it is, it needs to go twice as far over. This blue dot here needs to, instead of going over 4, it needs to go over 8. So the red dots would be my final answer. And then I go back in with my eraser and get rid of the parent points. There. So those 3 dots are a good enough answer. Yes, technically we'd connect them with a line, but it makes it so messy it's hard to read. I just leave them as dots. It'll save you time too. Okay, the next one's a V shape. I'd start with the parent one and it goes like this. Good enough, like do a few on each side. And then it says -1 on the inside. Always do the thing on the inside first. So you move it to the right 1 spot. So you can just put your dots in 1 spot over. Then make it 3 times as tall. Okay, the bottom dot doesn't get any taller because its height was 0. This one goes up to 3 times as tall, so I'm going to make these red now. 3 times as tall would be there and there. And then the outside points, over 3 and up. Instead of 2, I go to 6. There. And there. So there's my new dots. Just leave your your red dots in there. Erase out your others. Okay? Part C, I'll just give you a help quick. It says divide by 3, so I'm going to times by 3 on both sides. And the next part says +6, so I'm going to subtract 6 from both sides. So now I have my new equation, 3x minus 2 squared minus 6. Now, this one's tricky. You got to do so many things. You start with the parabola, you move it to the right 2, you make it 3 times taller, and then you move the whole thing down 6. Now, could you do this another way? Yes, and I want to give you one more way you could do it. And a lot of kids use this on the hard ones on the test, and they get them right. You start with what the parent points are, like for x and y. And the parent points for a parabola would be, here's the parent, over 2 up 4, over to -2 and up 4. Okay? And then they do all of these things to those points. So let me start by writing the points down. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now I just go in and I take all of my x values and I do the opposite of what you'd think. I don't subtract 2, I add 2 to all of my x's. So add 2 to this, and 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 add 2 to this. And then what do I do to my y's? I times them by 3 and then subtract 6. So I times this by 3 and then subtract 6. Times by 3, subtract 6. Times 3, subtract 6. Times 3, subtract 6. Times 3, subtract 6. And then you'll know exactly where your points should be. So instead of trying to move it and flip it and then move it again, you can do it this way where you can say, all right, I know I got to take my x's and add 2 to them, and I got to take my y's, times them by 3, and subtract 6 from them. And when you do this, my final point, like here, 2 plus -2 would be 0, comma, 12 minus 6 would be 6. 0, comma, 6 is my first point that I have to graph. So over 0, up 6, there's my first point, my answer. Next point would be 1, and 3 minus 6 would be -3. 1, comma, -3. Over 1, down 3. and then you just graph the rest of those points. Connect, well, you don't have to even connect the dots, but it should look like a parabola that's been moved to the right, stretched 3 times taller, and then moved up 6. Yes, you start with this, then you do this. Yep, the -2 is first, and then the times by 3, and then the subtract 6. Unless you want to do it this way I just showed you, which is make all your parent points, and then make them figure out where they move to, and then graph all the parent points again after they've been transformed. Whichever way you want to do it. I will say more kids make mistakes trying to freehand it. This way is more mathematical, and therefore is probably, I don't know, more accurate, but it all depends on how careful you are. If you're really careful with the other way, it'll work fine too. You can do it either way. Just have to have it in the right spot. If any of your dots are in the wrong spot, it's going to be wrong. Yes? Yep. All right, so the question is about D as in dog, and I'm going to slide up to so you can see that. Let's see here, get up to D. All right, so yes, you're supposed to take your shape. I'm going to move this divide by 2 and put a 2 in front. So it's pi equals 2, and I'm going to put it like this. Do you agree that I should start on the inside and therefore do 4 times wider? Okay, so I take my V shape, which would normally be like this, and I make it 4 times wider. So I'm going to do that in green. So instead of over 1, I'm going to go over 4 now. Instead of over 2, I'm going to go over 8 now. Same deal here. So now you can see my V is stretched out a lot. The green one's much more stretched than the red one. And now I have to make all the points go twice as tall. So now I just take, I'm going to do this now in blue. Still have a spot there. That hasn't moved yet. And I make this green one go up to twice as tall, which would be there. And this one to twice as tall, which would be there. And this one to twice as tall, which would be... Wait a minute, I only made that one. I made this green dot is off a smidge, I think. Yep, that one right there should be over 4. There we go, sorry. And then that one should be up to twice as tall. So it's there. And this would go there. And now, connect those blue dots and you have your answer. Yes, if you want to make the table like this, and start with the parent points, which we're at 1, 1, and 2, 2, and 0, 0, and -1, 1. And then do this to them. Take these and times all the x's by 4. So the 1 times 4 is 4, 2 times 4 is 8, 0 times 4 is 0, and -1 times 4 is -4. And then take all my, that's y thing. I make my 2 times taller, could be times this by 2. 1 times 2 is 2. 2 times 2 is 4. 0 times 0. And 2 times that is 2. Graph those points, and you'll have it. But it's going to end up being the same exact thing as what I just did. See? 4 2's right there. 8 4 is right there. 0 0 is right there. And -4 2 is right there. So yeah, I was doing the same exact thing. That's both ways you could do it. Okay, you pick which way you like better. All right, that's the end of the video for today.